This question is to prove that e to the power of ix equals cosine x plus I times sine x. So in the complex analysis study, when we learn the chapter of the series expansion, we know e to the power of z can be written using a series of the functions 1 plus z over 1 factorial plus z squared over 2 factorial plus z to the power of 3 over 3 factorial, and so much like this. So in this question, we're going to use this series expansion form to prove. So if we assume z equals ix, we just need to substitute into this series expansion form. So e to the power of ix becomes 1 plus ix over 1 factorial plus ix squared over 2 factorial plus, we can have 3, 4, 5, 6. And probably you have already noticed we have I squared I to the power of 3, 4, 5, 6 in this equation. So let's do some simplification. We know I squared equals minus 1. So I to the power of 3 is minus I to the power of 4 is 1. I to the power of 5 becomes I again, and I to the power of 6 is minus 1. So let's rewrite this. E to the power of ix becomes 1 plus ix minus x squared over 2 factorial minus I times x cubed over 3 factorial plus x to the power of 4 over 4 factorial. And you can just keep writing until some stopping point that you are satisfied. But here I just stop at 6. And in this step, we need to do something to rearrange this function. So let's do this. Let's make those parts which have even numbers in the denominator parts into one group. Here I marked the blue lines underneath. And let's make the other parts as the second group. So e to the power of ix can be rewritten using these two parts, the blue one and the red one. So you can double check to see if there is any mistakes I made. Okay, and for this equation, for the second part, the second parenthesis, we know we can move I outside of the parenthesis. So now we have this equation to be used to represent e to the power of ix. So here, I'm pretty sure some of you may have already noticed that, wait a minute, the two parts within the parenthesis seem so familiar. And that's right. In the chapter of the series expansion, we also learned the series expansion forms to write to represent cosine z and sine z. So the first part within the parenthesis is cosine x. You can double check to see if they are consistent. And the second part within the parenthesis is sine x. So we just need to substitute. So e to the power of ix now becomes cosine x plus I times sine x, which is exactly consistent or same as the question.